I'm not leaving.
Hey, we got
All the
PT2
stuff
today,
was
guys.
done.
Yeah.
We put it on
No,
there.
we finished.
Okay.
Says who? So we're gonna leave there the garage floor?
We finished it. We just haven't done
I don't think there's no PT2
it. I
today.
did contribute.
I thought
I
we're
showed
having
up
PT2
to
today.
And I
You
just
said
hung out.
that, but
Yeah,
we
you
finished
showed
it.
up 3 hours late.
Oh, hold
here we
on.
go.
Don't sit there act like I wasn't contributing.
All right, here we go.
I was gonna say.
Refocus here. All right, so what we've come up with here, we got a stair-step line, right?
Right.
Everything on the left is a metal. Lose electrons to form cations. Everything on the right will gain electrons to form anions, except for the noble gases, which already satisfy the octet rules. They don't gain or lose anything. The first column metals are all going to have one valence electron and lose that valence electron to make a 1+ cation. Second column metals have 2 valence electrons. They're going to get rid of both of them to make a 2+ cation. You come back over here, the 17th group, known as the halogens, have 7 valence electrons. They pick up 1 more to make a 1- anion. Oxygen group has 6 valence electrons. They pick up 2 more to make 2-. Nitrogen group picks up 3 more. Carbon and silicon would pick up 4 more to make themselves stable. In other words, to satisfy the octet rule. The question is, what about from group 3 over to the stair-step line? Here's a group of metals. Of course, this includes this bunch down here, but we're not going to get into them. But what do you do with these guys? Okay. When it comes to this group, what we have is often multiple stable ions of the same element. The best example, the most common example, is iron. So, if we take a neutral iron atom, okay, that's the orbital diagram for a neutral iron atom. If I agree with that, 6 electrons. To make a stable ion, it's going to first do what every metal would do, and that's lose its valence electrons. Well, how many does it have? How many valence electrons are in iron? 2. That's 26 total electrons. 2 valence electrons. Because it's the electrons with the highest number, right? Highest energy level or highest principal quantum number. So these are the valence electrons of iron. Okay? So it's got to lose those, just like every other metal does. That would make it iron 2+. Still has the D electrons out here.
So everything in that area is just 2+.
Not necessary. Most are, but not all of them. We'll get to that in a minute. Yep.
So, what happens if, say, the electrons were complete in iron? What would happen?
If they did what now?
Say if they're all complete in 3D, would it be 8? What would it be like?
Like if these were all full,
Yes.
iron wouldn't do that. That would take way too much energy. Because it wants to get rid of stuff, not pick up more.
So it goes this way.
What now?
No.
Okay.
Okay.
All right. So one of the stable ion. Oh, go ahead.
So when we are like writing down whether they're losing or gaining electrons, do we always take the valence electrons
Yes.
first?
So metals lose the valence electrons. Yeah. That's a near as a fact. It's near of a fact that there is in chemistry. It's always been said. So first thing we can do to have one of the stable ions of iron is take away its valence electrons. But if you look at this for a second, there's kind of an odd man out right here, right? So everybody's unpaired. You gotta remember the electrons don't like each other, right? So
Yeah.
these 4 electrons are really perfectly happy because they've got a whole orbital to themselves, okay? But what we got going here, these are paired. It would be very easy to take that electron away from iron. If another atom came along and wanted that electron, iron basically wouldn't argue with it very much. It would let it have it. Okay? So if that electron went away, that would be iron 3.
Iron 3 what?
Plus. Iron
Oh.
plus. It's lost 3 electrons now. So both of these are possible. Both of them exist in various compounds. So these are 2 stable ions of the same note. Question? You figured that out?
No,
No?
why is there another one up if it lost 3?
Lost these 2. This one has lost those 2 and that one.
Okay.
So we took those 2 away first. That made iron 2 plus. And if we take that one out of a 2 plus, we have a 3 plus.
Oh, okay. You took out the
Take out
the
1.
4s block.
Okay.
So you could just take that out.
Well, another atom would take it away from it.
Okay.
We'll get to that part.
So it's
A couple
like-
more units, but
Just take the ball in. Okay, I got
it's
it.
kind of,
Yeah,
okay.
like
Yeah.
Strip said. Got it.
Okay.
I got it.
This electron is like the read option with a scared quarterback.
Right.
So
He gets
he's supposed
absolutely
to give it up,
annihilated.
but if you want to take it away from him, he'll give it to you.
Okay.
Whether Reed says that or not, he'll just give it to you anyway, because he'd rather you get hit than him get hit.
Okay.
You know,
Yeah.
I needed to go to like high school girl drama.
football team.
Okay, so.
It's like throwing it up in the double coverage.
So Becky has to be separated. Can you make an analogy using like high school girl drama instead of
Oh my gosh, let's see,
It's like Rebecca giving away her boyfriend to you, Penny.
Whoa.
I heard, well, okay, I had a chemistry teacher at a conference one time give an explanation one time that was, I thought, highly inappropriate for teenagers. So I'm not gonna go that route, but,
I think we should hear it.
no, it was like, I'm just sitting there thinking, you can't say that in high school.
Chloe, close your ears.
Yeah.
So,
You're in the 10th grade, dude. Like, close your ears.
so we got 6 mean girls,
Okay.
okay, right?
I can picture them.
And they can tolerate each other if they're not all sitting next to each other in class.
Right.
But if one of them has to sit really close to the other one, okay,
Right.
especially if that one's a little bit different from the rest of them and therefore is a target, okay, then it's very likely either to get, not necessarily, mean girls won't like openly kick you out of the group, right?
Right, it's
But
all
they're not-
subtle.
It's all subtle. So when that person decides to go sit somewhere else, or if somebody comes along and says, hey, you want to come sit with us, they're gonna not resist that, and then they're probably gonna talk bad about it behind their back.
Right. Okay, that makes sense.
So it's like Regina George getting rejected by her friends because she wore sweatpants on jeans, man.
Right.
If you've ever watched the movie Mean Girls,
I haven't actually.
it's a great movie. You should watch it.
You haven't watched that scene?
It's kind of a cool
And you can't wear the same pants 3 days.
You can.
Dude, no, like actually, it's a good movie. I have sisters, so I watched it.
All right,
You never seen it?
I have not.
okay.
I have not.
So let's practice with our
Let's practice.
mean girl analogies.
I'm a mean girl.
Yeah. Mean
And
girl
then I
chemistry.
texted the group chat, was like,
Chromium.
I don't think that nobody.
Find chromium on your periodic table. Where's chromium?
Chromium. It's
24.
24. All right, so I want you to draw 4 things. Draw neutral chromium, okay, first, and then chromium has 3 common ions. Jot this down. 3 common ions of chromium are 2 plus, 3 plus, and 6 plus. 2 plus, 3 plus, 6 plus. So draw 4 orbital diagrams, one of neutral chromium, one of chromium 2 plus, 3 plus, 6 plus. In about 5 minutes to do that right quick.
Confused. Chromium 24.
Start with neutral chromium, okay? And then try to figure out how to form a 2 plus cation.
Bless you.
And then
Let's
after
see.
that, see how you can make it 3+,
Let's see.
and then 6+.
Gosh. You're so Hollywood, dude. It's not cool.
Okay, so what? What is this?
Listen.
Alright, draw the neutral line first, so just draw it normally.
Yeah, I did that.
Okay. And now
Now I
you're
just take it out.
yeah, take out the valence electron first.
Oh.
Your 2 plugs.
Oh, I got it, I got it.
Y'all got this, guys. Especially you, Corey.
A neutral 2 plus 3 plus 6 plus.
But are you allowed to take individuals out? I'm going crazy right now.
Maybe, sometimes not.
Like, if it's
Figure it out.
like this, because that's the only way to make 3 or 6.
First thing, you gotta make sure you take the valence elect, that's a must, right?
I do that now.
That's got to go, okay?
Okay, this is gonna be easier. I thought it had to have a pair.
Doesn't have to have a pair.
Then why can't you make it like 5 plus?
It probably exists, it's just not as common as those 3 I gave you.
Okay, so this can be like almost.
So in chemistry, almost everything's possible.
Okay.
It's just some things are not practical. And some things just don't ever really happen very much. But there's always an example of just about anything. Chemistry kind of has
Yeah.
limited
2
possibilities.
plus 3 plus 6.
Okay. 2 plus 3 plus 6
So when you
plus.
start being like, well, couldn't it do that? Probably.
Oh my God.
So gonna
If it
be.
ever do that, you have a problem.
I think.
Maybe possibly probably not.
Or did I just say? I just took out another electron. That's what he did up there.
No, but the thing about that one is he took the one that was, he took Regina with her sweatpants out.
It's because she was getting fat though, because
Because she was getting fat.
It's,
Yeah.
you know,
She kept-
it,
well, I
think
think
so.
protein-
it's because she was getting fat because
She was eating protein bars that give her weight.
no, it really wasn't. It was like
It was a trick because she
You
thought.
talking about the movie?
yes,
Yeah.
it was like she was
Make sure we're
like
not talking about
giving
somebody's
like
right.
she was giving this
No,
girl.
alright, like they were trying to make her gain weight, right? Because she's always a skinny queen.
Yeah, and
So,
she's
they
like
gave her a protein
top
bar
number
telling
one
her, oh, it's gonna
female.
make you skinny, it's gonna make you lose pounds.
It's
She's like,
what the
okay,
football
but
players
so
would
she
eat.
only ate that and she started gaining weight. That's why she wore sweatpants to school.
because she couldn't fit her jeans no more.
Yeah, she
Protein bars
couldn't-
You gotta eat.
It was.
No,
But it's not- it's not a-
the football
Okay,
players.
it's full body
Katie's
sugar.
wrong.
Oh.
It's like a bar that's meant for African kids.
Yeah,
to
it was
gain
meant
weight.
for like athletes to help them like.
No,
build
African.
muscle.
And for African kids, because she came from Africa, and that's what her mommy did.
Right.
And the bar was in a different language,
Yeah,
so she
yeah,
couldn't
Swedish.
so she couldn't read the macros on it.
It was Swedish. Oh my god, all the memories are coming back.
Swedish candy bar from Africa.
No, Swedish candy
It
bar
makes
for
people fat.
African children that are malnourished.
Wow.
Correct.
That's a confusing movie.
No, it's a great
It's
movie.
very good.
The
We need
plot
to
is
watch
very
it.
We should do a film analysis on it.
Yeah, that's what I was gonna
Wrong
say.
class.
And pull out all the
Mr.
aspects
Fatal
of
should- You
chemistry.
should go home and watch it, and then that should be our homework tonight.
You know-
Go watch it.
I had it 3 times.
Hey Cole, what'd you do last night when you left?
What?
What'd you do like after you left, like working on the homecoming float?
Oh, Raven.
Oh, you were home?
Like, do we
Oh,
have
no,
one
it's like-
before this?
I was exhausted.
Oh, that's what I did.
Right, so there's neutral chromium, right?
Hey Emma, what'd
Yeah.
you do?
Raven.
So
Watch TV, went to
What'd you
sleep.
watch?
I can't even remember my.
Well,
my
I did
film or
watch
answers
something
from
too.
reason why I remember to watch. No, but I should have fallen asleep because my house got rolled.
It's okay.
So if you take away the valence electrons, which is always
Yeah, well,
the first possible thing that's
it
gonna
was
happen,
so good.
and you get 2 plus, right? So what do you have to do to get 3 plus?
Take another one.
Take another one out. Okay, so they're gonna go out in the opposite order that they go in. So that one's gonna go out. Okay, so that's 3 plus. How you gonna get the 6 plus? Take all the rest of them.
Well, how is the other one?
So smart.
Genius, I've been chemistry.
It's the
God,
teacher.
so unenthusiastic. I need blue. I need more.
All right,
Okay, that makes sense.
It feels like new.
Yeah, that makes
It does
sense.
look-
makes sense?
Yes, it does.
No, I don't even have to write anything.
Leave it blank.
That's it, yeah.
So like on our last quiz, like if I would have wrote that and just put 6 plus, so would you have counted it for the shorthand?
That's a totally different question.
Wrong quiz.
Okay, my bad. What about on the next, what about the next quiz or test?
Having your bags on fall.
Which one's the question? That was the question.
Okay, never mind.
It's Zach's.
I'm sorry.
Gabby, you did that.
I'm gonna say you did too.
All right, so real quick, if we look at the seven atoms that are configured on the board right here, do any of them have a noble gas configuration?
I have no idea what you just.
Yeah, what do you mean by that?
What does that mean?
Yeah, what does that
Isn't
mean?
that what we just?
What do you mean?
I thought that was the whole point of this.
It is the whole point of it. Did we actually achieve it for any of these, 7 of these things?
Hope so.
Hope so. Well, which one, where? All of them?
6 plus.
6 plus, right? Okay.
Thanks, Xander.
So chromium 6 plus, chromium 6 plus has an actual noble gas configuration,
Well, that's crazy.
all right? These two, okay, right here,
No.
and these two, all right, have what's called a pseudo noble gas configuration.
Okay, that's what it's called, pseudo noble gas.
Pseudo noble gas configuration. So pseudo means sort of.
In
Oh.
what language?
Latin.
I thought-
Latin.
I thought
Why
pseudo
can't
was
Like
a,
it'd be Hebrew and be like Dutch.
isn't it like a
That's
type
a
of,
lovely language.
I know, right?
like?
But like
pseudo-
every little
Pseudo-
suffix and
that's-
whatnot is
that's-
Latin.
Okay,
or
yes,
Greek.
okay, I didn't know that.
Same pronunciation.
Why did the Dutch
Better.
exist?
I didn't know
I
that.
mean, they just took a little while to get this out. What is that?
It means it's sort of a noble gas
Why did
configuration.
the Swedish give us that?
It's a noble gas with some d electrons still kind of hanging off the edge. Okay,
So,
so for these elements in here, okay, for these elements in here, sort of noble gas configuration is stable. They can be sort of like a noble gas. They don't have to be completely like one. Right? They might be completely like a noble gas. They might have an actual noble gas configuration, and that, of course, that's fine. But they might just be sort of like one. So pseudo noble gas configurations are okay for these elements in here, and that allows them to have multiple stable ions. At least some of them do, some of them don't, but some of them do.
on the iron, could you do like plus or 8 plus,
Good.
and then it would be
It's not common. There's other forms of iron, but these are the 2 most common. Those are the 3 most common forms of chromium. There's also a chromium 4 and 5.
I'm good.
Okay, so those are, you find those most often, are those the ones that are naturally made?
Yeah, if you go out in nature and start looking for compounds that contain iron, you're most likely going to find iron 2 plus and iron 3 plus. There are some others, but they're rare.
Oh,
Iron 6, 4.
Alright, so for like a test question, you'll be like, find the 3 common ions for chromium, and then you write out those 3.
wait, but
So we're not
how,
just making whatever we want.
are we supposed to know that the common ions of chromium are 2
Well-
plus 3 plus 6 plus?
for the family.
You wouldn't have to give me the common ones. I would just say give me stable ions of chromium. So one answer is always take away the valence electron. That gives you one answer. And then if you have d electrons left over, you can take those away. As many as you want, theoretically. So they're gone. One thing that normally happens, and one reason that this one is so stable is for reasons that are way past this class. Atoms sort of kind of like it when their orbitals are either empty, half full, or completely full. So that's one thing that iron 3 plus has going for it, is the D is half filled. It's got 5 of the 10. So like D orbitals hold 10 electrons. Stability is found when there's 0, 5, or 10. That's not always the case. There's enormous numbers of exceptions and weirdness that takes place in that area of the periodic table. So there are no wrong answers to the question of draw a well, I mean, there are, but if the question was draw stable ions of chromium, if you take away the valence electrons, you got a right answer. If you take away any number of d electrons, you have other right answers. As far as which ones are the most common, that would just require you to memorize stuff. We do that.
Gracias.
And I looked that up this morning to see which ones are the three most common.
Okay.
All that. I do know that iron 2+ and 3+ are the most common forms of iron. That's the most sort of famous example of all this. So yeah, you can know that. But as far as the rest of them, Google what are the most common ions of copper or vanadium, whatever. There's all kinds of ions of each one of them because they can lose individual d electrons. At least theoretically, they can lose them. But for various reasons that are complicated and beyond this class, some of them don't really have any rhyme or reason. It's just what they do. There's certain arrangements that nature seems to prefer. So they're more commonly found in nature. Doesn't mean there's not others.
Do you got a favorite like element on the periodic table?
That would be the really nerdy thing.
I think it's iron.
Mine is
I think your
perfect.
favorite is
I
iron.
think I'll go oxygen because it's breathing.
Oh my god. Oh my god. I thought it was just the air.
I need air to live.
I was prepared.
Huh.
I think mine was cobalt.
Carbon would probably be, I mean, it's, my organic chemistry background makes me lean towards carbon.
Mine's carbon.
Basis
It's a fun
of
one.
organic chemistry and
Why is that?
I think bromine is my favorite.
bromine.
Yeah, just because it's like bromine, like it's the name.
Bro-
Oh, it's actually
Yeah.
natural.
Personally, I like silver.
Silver. I thought you were going to the mayonnaise.
Alright. One more little bit of terminology.
You're not
here
like
for just
that,
a second. I'm just telling you about that.
You never lied.
Biology.
Good. Turn it down. All right. So the term oxidation state,
This is oxygen.
also known as
Pretty
oxidation
sure we
number.
would have been friends. She's awesome.
So these are interchangeable terms. All right, and it means the number of electrons gained or lost to become stable.
What is this?
I think you're too tough for you, it's just aggressive.
All right, so oxidation state or oxidation number, you can completely interchange those two terms. Okay, it's the same thing. Or the number of electrons gained or lost to become stable. Now, what's kind of annoying about this is it's basically the same thing as the charge in most cases. We will see later on that there are exceptions to that also. But what we have here is, looking back at this periodic table, since the charge of every group 1 metal is 1+, that means their oxidation numbers are +1. The charge of all the group 2 metals is 2+, which makes their oxidation state +2. Okay? So it's simply a matter of how you write it, really. Now when we get to covalent bonding, we'll see that there's some differences. But so if we go over here, the oxidation state of the halogens is -1, the oxygen group is -2, nitrogen group is -3, so on and so forth. Okay, we're talking about the non-metal parts anyway, but so metals are going to have positive oxidation states and non-metals are going to have negative oxidation states. if we want to be really, really technical, which I'm not going to be, but just in case you have a real jerk of a college professor like I had, the technical way that you write a charge is number sign, and oxidation state is sign number. And I had a professor who would take off points for that, which I thought was ridiculously rude. I don't do that because AP exam's not going to do that, so we're not going to be that way. But just for the record, charges are supposed to be written number, sign, and oxidation numbers are sign, number,
What?
even if they're the same thing.
No, I was gonna
Do I?
ask what, but don't even.
It's just the conventional rule that's used. I didn't come up with it,
Out of curiosity, I wonder why they did that.
but I don't know why they decided that had to be that particular. Okay, now,
Oh, the one with the head.
all right, how we doing? Here's what I need y'all to do tonight, okay? For your own personal practice. Prove to yourself, do a couple of group 1 metals and prove to yourself that they've all got 1 valence electron and make a 1+ cation. Do the same thing for group 2, group 17, 16, 15, okay? Just prove to yourself the numbers of valence electrons and charges of those stable ions. These metals and all the non-metals have 1 stable ion. It's in here that we run into 2 or more stable ions. So as another practice here, lead has a 2+ and a 4+. Now lead is a p-block metal, so it operates a little different. See if you can figure that out tonight, how lead could have a 2+ and a 4+.
Because I said so.
How you said so. All right, works.
Yeah, but then you in the front of them, I flip back up.
All right, any questions, comments, problems? Yep.
Could you explain valence electrons?
The ones are the outside ones, valence electrons, and they have the highest energy, the highest personal quantum number. So like with iron, you got 4s and 3d, right? 4 is bigger than 3,
Oh, okay.
so those electrons are the valence electrons.
Okay.